Hello people, here you have a test screen for the ZX Spectrum Plus 2 using the RGB2VGA FPGA board. As you can see, the colors are perfectly captured. It's hard to see the blue, but there's two from far. You can see there's two shades of blue. I also how the pixels are stable. I also changed the shrink algorithm to perform a linear interpolation. Instead of I was using a box filtering, and now I have a proper linear interpolation being performed in the board. I can better show you using a game. Just the camera is out of focus. For example, I have this nice screen which is untrinket. You can see the pixels, how do they look like. Now I'm gonna shrink. You can see, although you see some looks like some lines here, that's because the color resolution is not enough to perform a smoother. This is why you see some, and also the pixels, but it's way better than before because of all the pixels are being averaging using distributed weight along the scan line. If I show you here, before I was using the box filtering. So for the box filtering, you get here 8 pixels, and they are shrinked in 7 pixels, being the last pixel an average between the last and the next pixel. And what's bad in this algorithm, that whenever you have a scroll and you pass here, so you have a missing pixel. You see there's like a worm moving. There's a little wave, and this is the linear interpolation. The linear interpolation will take 2 pixels, consecutive pixels, and blend them along distributed lines. For example, this is the first pixel. You get 1 pixel plus the second, but in first line you take 7 parts of the first pixel, 1 part of the next pixel. The second pixel will take 6 parts, and 2, 5, 3, until you have 4 and 4, which is half and half. Until this repeats into the last 7th pixel, have 1 part of the first and 7 the other, and the algorithm repeats itself. As you can see in this linear interpolation, we have all pixels, they have the same size, right? Not quite exactly, because the real pixel still is this. If you look here, this is the real pixel. This is the real pixel looks like. So, and then what the algorithm does, it takes the two and average them. So you have a distribution of the pixel. It becomes like a blurred, something like. And this is what it makes the linear interpolation a better distribution of the weight. This can be seen on, if you take a scrolling game like R-Type. Just have this banner passing all along, but we take a shrink. Cool. Then you can see the scrolling lines. Although I told you that about the color being, but you see the pixels, they always keep the same size. They don't disappear in the middle. This makes much better for the eyes. Of course, you only want to use that if you really want to keep the original aspect ratio. Otherwise, you use the unshrinked version. So that's it. The border now accepts the spectrum video, and I have to set a different clock for that. The spectrum operates in a different speed. I had to find the correctly values for the PLL. And